Scalar products. Now in question 1 we have to find the scalar product of the vector 3i minus 2j and b 2i plus 5j, and it's a very simple operation. The scalar product, which is a dot b, is equal to 3i minus 2j and 2i plus 5j. Now the multiplication is very simple, because all you need to do is multiply these two together, which gives me 3 times 2, which gives me 6. And these ones together, minus 2 times 5 is minus 10, which gives you minus 4. All the others drop out because an I and a j will give you a 0, but the i's will give you the 1s. And that's the scalar product, that easy. Now in this case here, we have to work out, given the vectors 3i plus pj and 2i minus 3j, we know they are perpendicular at right angles to each other. We have to find the value of p. Now, the dot, if they are perpendicular, then the dot product is simply equal to 0. We'll look at why that is a bit later on. So now we'll multiply them together. We go 3i plus pj times 2i minus 3j. And we know that's equal to 0. Multiplying just the i's together, we get 6. Multiplying these together, we get minus 3p equals 0. So 3p equals 6. P must equal 2. Scalar products number 3. The angle between this vector 2i plus 3j and this vector 3i minus j is, now what we do is use this formula, right, to work out the angle between two lines. So we say that the cos of theta is equal to, now a dot b is just simply going to be 2i plus 3j times 3i minus j all over, now this would be the magnitude of a, and the magnitude of a is going to be the square root of 4 plus 9 times the magnitude of b, which is going to be 9 plus 1. So it's going to be equal to, multiplying the tops together, we're going to get 2 times 3 is 6, and then 3 times minus 1 is minus 3, over becomes the square root of 13 times the square root of 10, which is equal to 3 over the square root of 130. And when you bring out your trusty calculator, you'll find that that's going to be, the inverse cos of this is 75 degrees, approximately. Alright, in number 4, we're given that OABC is a square, where OA is 3i plus 2j, OB is 5i minus j, and OC is 2i plus pj. Now given that the diagonals intersect at right angles, I'm going to find the value of this p. First of all, we need to find out what AC is, right, because this is one of the diagonals. To do that, we'll say that OA plus AC, OA plus AC will be equal to OC. Right, therefore, we can say that AC must be equal to OC minus OA. So what's this OC? OC is 2i plus pj, and OA is 3i plus 2j. Therefore, that's equal to minus I plus P minus 2J. So that's AC. Now we know that OB, this one here, OB, is equal to 5I minus j. Now we'll work out the angle between these two vectors using the formula we had before. The cos of theta is equal to this vector here, which is AC, times the other vector, which is OB, over the magnitude of these vectors. Now, because they're meeting at right angles, we know that theta must be equal to 90, and we know that the cos of 90 is 0. So if that's 0, then all we have to know is that AC times OB must be equal to 0. We don't need to work out the magnitude. So therefore we can say that AC, which we found was this one here, minus I plus P minus 2J times the other vector, which is 5I minus J, must be equal to 0. Multiplying these two together, we get minus 5. Multiplying these two together, we get minus bracket P minus 2 equals 0. Removing the brackets, we get minus 5 minus P plus 2 equals 0. So here we get that P must be equal to -3. So P was -3.